In this video, we're going to talk about wire size, wire gauge, amperage, diameter, and other things related to this topic. Perhaps you've seen this abbreviation, AWG. This stands for American Wire Gauge, and it tells us the size of the wire and how much current it can safely handle. So the picture on the left represents a wire gauge of 10. The one on the right represents a wire gauge of 20. Now, what we need to understand is that the higher number corresponds to a smaller wire. A wire gauge of 10 has a diameter size of about 2.588 millimeters, whereas a wire with a gauge of 20 has a diameter of 0.812 millimeters. So as you can see, as the wire gauge increases in number, the diameter, or the size of the wire, decreases. So these two are inversely related. A wire gauge of 10 can handle a current of 30 amps, whereas a wire with a gauge of 20 can handle a current of 5 amps. So as the gauge number increases, the amount of current that it can handle decreases. Now the other thing we need to talk about is the resistance per unit length. The resistance per unit length of a wire with a size of 10 is 1 milliohm per foot, whereas the resistance per unit length for a wire with a size of 20 is 10 milliohms per foot. So as the wire gauge increases in value, the resistance per unit of length increases as well. So these are some things you want to keep in mind. So as the gauge number increases, the diameter size decreases, the amount of current that it can handle decreases, but the resistance increases. So here we have a table that lists the wire gauge, the resistance per unit length, the diameter size, and the ampacity, or the maximum current that the wire can handle at 60 degrees Celsius. Now the first thing that we can focus on is the relationship between the wire gauge and the resistance. As was mentioned before, as the wire gauge, as the number increases, the resistance per unit length increases. But notice that when it increases by 3, the resistance doubles. In this case, as it goes from 4 to 7, the resistance per unit length goes from 0.25 to 0.50. And as it goes from 17 to 20, we can see that the resistance doubles from 5 to 10. So every time the wire gauge increases by 3, the resistance per unit length increases by a factor of 2. Now the second thing to notice is as the wire gauge increases by 10, the resistance increases by a factor of 10. So as we go from 20 to 30, the resistance increases from 10 to 100. So an increase of 10 in the wire gauge leads to an increase of a factor of 10 by the resistance. So those are some things that I caught looking at this table. Now the next thing that we can see in the table is that as the wire gauge increases from 0 to 40, we can see the diameter size decreasing progressively. And finally, as the gauge number increases, you can see that the ampacity, the amount of current that the wire can handle, decreases. So this just confirms what we talked about earlier in this video. It turns out that there's a formula that you could use to calculate the diameter size if you know the wire gauge number. And here it is. D sub n is equal to 0.127 millimeters times 92 raised to the 36 minus n over 39. So let's plug in 20. So n is going to be 20. So this is going to be 0.127 times 92 raised to the 36 minus 20 over 39. 36 minus 20 is 16, and 16 divided by 39, that is a long decimal number, so I'm going to leave it like this. Go ahead and type that into your calculator. So 0.127 times 92 raised to the 16 over 39. You should get this 0.8118 millimeters. So that is the diameter size given a wire gauge of 20, which corresponds to the data that we see here in the table. So that's the formula that you could use if you want to calculate the diameter size in millimeters if you know the gauge number. Now let me erase a few things. Let's work on a problem that we have on the top of the screen. A variable power source is connected to a 14 gauge wire that has a length of 9,000 feet. What is the maximum voltage that can be safely handled by this wire at 60 degrees Celsius? Let's begin with a picture. Let's say this is the wire. Let's call this points A and B. What is the maximum voltage that can be applied across this wire? Now this wire has a length of 9,000 feet. It's a very long wire. How can we determine the maximum voltage that can be applied? Well, we could use Ohm's law. V is equal to IR. The wire has a certain amount of resistance, and there's a maximum current that it can handle. So this is a 14 gauge wire. Using the table, we could see that the maximum current that it can handle at 60 degrees Celsius is 15 amps. So we have the maximum current. So we're going to replace I with 15 amps. Now the only thing that we're missing in order to calculate the voltage is the resistance of the wire. How can we determine that? Well, for a 14 gauge wire, we can determine the resistance per unit length, which is in milliohms per foot. And that's going to be 2.5. But let's convert that to ohms. So we have 2.5 milliohms per foot. And there's 1,000 milliohms per 1 ohm. So this is going to be 0.0025 ohms per foot. The resistance is going to be the resistance per unit length times the length of the wire, because those are going to cancel out. The resistance per unit length is 0.0025 ohms per foot. And so we're going to multiply that by 9,000 feet. So we can see the unit feet will cancel. And so it's 0.0025 times 9,000. And the resistance of this wire is going to be 22.5 ohms. So we can plug that into this formula. And that's going to give us the maximum voltage. So let's multiply 15 by 22.5. And that's going to give us a maximum voltage of 337.5 volts. Anything higher will exceed the maximum current rating of 15 amps for the 14 gauge wire. And so that's it for this video. So now you know the relationship between wire size, resistance per unit length, diameter, size, and the maximum current that it can handle. So thanks again for watching, and don't forget to subscribe to this channel.